Let's look at converting radical expressions to expressions with rational exponents to be able to simplify logs, okay? So first, let's talk about this conversion of a radical expression to an expression with a rational exponent. Here's an example. We have the cube root of x squared. Now notice that the base underneath this radical is x, so we're going to keep that same base, but we're raising this to the power of a fraction. So rational means fraction, and that fraction is going to be the exponent of the base under the radical, so 2 in this case, divided by the index. So in this case, this is a cube root, so the index here is going to be 3. So this will be exponent divided by index. So as a quick note, if we have the square root, its index is understood to be 2 because it's square root. Okay, so let's look at some of these examples, and we're applying this now to logarithms. Remember that we have the rule that if we have log base b of b to the y, if our bases are the same, this is just going to be y. So that's really what we're going for with these problems. Notice that we've got a 3 and a 3, but this radical here is causing us a problem. So we really need to convert that to an exponent so that we can use this rule that we have. Okay, so this means we're going to have log base 3, and we're converting this square root of 3 to the 5th to be 3 to some power. So our base is 3. What is the exponent here? That's going to be 5, but what is the index here? We can't see that, but that's understood to be 2 because this is a square root. So we're going to raise this 3 to the 5/2 power. Inside over outside. If you've seen previous videos, I did the backward C thing. That still applies here. It's going to be 3 raised to the 5 divided by 2. Now that we've done that, we can see that our bases are the same, and that exponent of 5/2 becomes the answer. So this is kind of a way to convert and get the answer very quickly. Let's look at the next one. Log base x of the fourth root of x. The fourth root of x, yes. So we're going to have this as log base x, and we want our argument to also have x in it. And the thing is, what is our understood exponent for x? Not the root, but the exponent. The exponent is 1, right? Understood 1. So this is going to be x to the 1/4 power. Inside divided by outside. You can almost think about that line for the radical being the divide. Okay, so this would be 1 divided by 4. Now that we have our bases the same in the log, that exponent of 1/4 becomes the answer. Looking at C, we have log base 9 of the 5th root of 9. Now, again, our bases can be anything, even numbers, and that's okay. So we've got log base 9 of 9 to some power. Okay, so what is the understood exponent for 9? Even numbers can have exponents. So this 9 can have an exponent, and it is understood to be 1. So if you don't see the exponent, it's understood to be 1. So this would be the exponent of 1, the index of 5. So this would be 1 divided by 5. So 9 to the 1/5. Now our bases are the same, and our exponent is the answer. Lastly, log base x of x to what power? You're going to see this over and over and over. So this is 1 on the inside, 2 on the index, so this would be x to the 1/2. And the bases are the same, so that 1/2 becomes the answer. If you're going into calculus, you need to know this, okay? Because you're going to see it a lot in that class. All right, so that's how you're going to convert these radical expressions to something that is usable in logs.